So let's look a little bit at how green homes save money. Number one, smaller HVAC systems. This was a house in Texas, by the way. That's only slightly photoshopped. They don't really make air conditioners that big. But a lot of houses have air conditioning and heating systems that are too big. HVAC contractors do this, and I see our HVAC contractor nodding in the back there. HVAC contractors do this because they feel like they're safer in oversizing. They're not going to get those comfort callbacks when somebody's air conditioner can't keep up in the summer or their heating system can't keep up in the winter. And they typically don't go through the full design process. In green homes, especially if they're in programs like Earthcraft House or Energy Star or LEED, you're going to get an HVAC design, at least more than a typical HVAC contractor is going to give a standard home. That means that the system will be sized properly, or at least a lot closer to properly than a typical home. The distribution of the heating and cooling will be designed better. For the Atlanta area, for the Southeast, when I talk about distribution, it's mainly air. If you go up north in Minnesota and Canada and places like that, where it's really cold, some of those people don't even have air conditioners. Though it's getting more prevalent, even in places like Toronto. But the distribution systems are designed properly, and when you do the load calculation to find the actual size that a house needs, it's typically about half of what most HVAC contractors want to put in. And I've seen this on so many houses. The reason is HVAC contractors use rules of thumb. And thumbs are great for a lot of things, but they're not good for designing HVAC systems. You need to use brains for that, and computer software nowadays. The rule of thumb is typically 500 or 600 square feet per ton. So if you got a 2,000 square foot house, your typical HVAC contractor working on a rule of thumb is going to say, we need a 4-ton air conditioner in that house. And a 2,000 square foot energy efficient house, 2 tons max should be enough to cool it. Because remember, with an energy efficient house, you're doing a really good job on the air sealing and the insulation. So you don't need as much cooling in the summer. You don't need as much heating in the winter. So this is another place where investing in a green home saves you money. It offsets some of the cost for the design and the better distribution system. But this is one of the big problems with typical homes. The HVAC contractors put their time and effort into the box, which is the piece of equipment, the condensing unit that sits outside and the air handler inside the attic or the crawl space, maybe in a mechanical closet or basement. And they don't think much about the distribution system. If you go into a house and look in the attic or the crawl space and see ductwork, if you see flexible ductwork, in a typical house, I can almost guarantee you that it's going to have all kinds of problems. And in a green home, it's supposed to be done right, and there are third-party inspections that help make sure that it's done right, and they measure the leakage in the duct system. They measure airflow. In the Energy Star version 3 now, the HVAC contractors and the raters have to measure the airflow, make sure that the system is commissioned properly so that it's moving the correct amount of air to every room. So that's one thing. Here I'm talking about ductwork. So this, anybody know what this is called? We have a name for this in the energy world. Spider, sometimes, or octopus, or ductopus. This is a classic. This was actually in the Atlanta area. I saw this several years ago. And I posted this online one time, and one of my friends said, "Release the Kraken!" Because that's what it looks like. This system is not designed. That's a system where the installer showed up with all their bags of ductwork. This is flex duct, and it comes in a bag of 25-foot lengths. And they showed up with all the bags of ductwork in the back of the truck, and they bring them inside, and they just start attaching them and dragging them to the places where they need to go. And there's no thought here about whether you're going to get enough airflow in the different rooms or not. It would be a miracle if something like this actually delivered the right amount of air to each room. This is an Energy Star house in Nashville. I just saw this in the summer. A beautiful duct system. And since it's Energy Star, it has to be commissioned so that the airflow in the different rooms has to be measured and make sure that they get the right amounts. We know how to do this. It's not that hard. Yes, it takes a little bit longer to do it right, but I would rather have a minimum efficiency air conditioner and heating system with a really good duct system than a super high efficiency heating and cooling system with a really bad duct system. Now, that's not to say that the really high efficiency units aren't good. It's good to have both. And, the best of all worlds, you have a really good distribution system and a really good heating and cooling system. So let's talk about those. The standard heating and cooling systems, like a regular air source heat pump or a furnace, an air conditioner, the minimum efficiency for an air conditioner that you can put in now is 13 SEER. If you put in a ground source heat pump or a ductless mini split, you're going to get about maybe double the efficiency. And you're going to save tons of money. In fact, we're not crazy about this, and I'm not bragging about it. We got a call recently from somebody in the Atlanta area building a house in Buckhead. Actually, it's a gut rehab renovation, an older house. And we got the call because they wanted to put in single pane windows. This is a high-end home and high-end single pane windows from Italy. And they were really attached to putting in these fancy, expensive, super expensive, like $800,000 window package. What? Yeah. Well, maybe not in this home, but the guy at the window company told me that they do $800,000 window packages on some homes. Maybe not this one, but so they wanted to put in single pane windows, and so they hired us to do the energy modeling because there are three paths to code compliance. One is prescriptive, and with single pane windows you can't do that. The other is looking at the efficiency of the building enclosure, the insulation, and the different parts of it. And that has minimum numbers that you have to use for windows, so they couldn't do that. They had to go the full performance method, which you do a home energy rating, which is energy modeling. And if you have enough efficiency in the heating and air conditioning system and more insulation in other places, then you can get away with using single pane windows. And it turned out in their case, the ground source heat pump was so efficient that it overcame all the losses from the single pane windows, and they are going to end up spending less on their energy bills than a house next door with a regular heating and cooling system and double pane windows, double pane low E windows. Let's go back a couple slides. Okay, so this is the outdoor unit on a typical air conditioner or heat pump. And in cooling mode, when you're removing heat from the house in summertime, you've got an indoor unit which is connected to this thing by the refrigerant lines. So used to be called Freon, now it's just called refrigerant. Runs through those two copper pipes, and it goes through this coil out here, and it's dumping the heat out here, and it's dumping the heat to the air. So this is called an air source heat pump or air conditioner. So you're taking the heat from the house, putting it into the outside air. In the summertime, the outside air can get pretty hot, like 95 degrees, 100 degrees sometimes. The hotter it is outside, the harder it is to do that. In ground source heat pumps, you're not taking that heat from the house and putting it into the air, you're putting it into the ground. And if you look at the systems over there, that one's got the plexiglass. It's got these plastic tubes that are buried in the ground, and they do it different ways. You can have the horizontal loops like this, shown here, or you can have vertical wells. And the picture right there shows a vertical well drilled in the ground, and they drop the loops into that well. So the pipe goes down, so the liquid goes down in there and comes back up.
Polarized getting
There are ductless mini-splits, and this is an example of the ductless mini-split. I don't have the picture of the ducted mini-split, but you can have a ducted mini-split as well, which will be hidden in an attic or behind the walls or somewhere. And it's got ductwork, just like a regular unit. But the advantage of mini-splits is zoning. They allow you to control the heating and cooling separately in different parts of the house. And with some commercial systems, you can even do simultaneous heating and cooling, where you take the heat from one part of the house and you bypass the outdoor unit altogether and send that heat to another part of the house. If one part needs heat and the other part needs to get rid of heat, you just send the heat one side to the other. When you size these things properly, they have longer run times, which helps them last longer as well, because what kills a lot of equipment is cycling on and off. When that switch goes on and it jumps up to full speed, depending on what type of motor you have in it, that's hard on it. And when it cuts off, again, that's hard on it. So it's the constant cycling in oversized systems that decreases the life of them. With a properly sized system, it'll last longer as well.